Okay, looking through one more time to your work. I'm going to go through this one more time. And this time try to do that so you can see between the two programs what it looks like. I'm going to start here with number 2, which is the most obvious one, because by examination you have to realize that this right here, that right there, and I'll try to use the rollover tooltips here, which is not necessarily working. The rollover tooltips there, you have to realize that this line is going to react all of its y up here for this force and all of its x over there. So the first thing we're going to do until you're completely facile with vectors is you're going to tend to move your origin around. Got to be very careful when you move it that you move it to the right spot. UCS to the end point of that, or the insert, hit and enter, and now if you look to this block you can see its position is 12.33, and the force, whether or not you slide it, is a very variable what you want to do, but what you go ahead right away do is you write ahead the moment of this force about this point here can be written this way. Well, you just go to here, (7.23, 4.38). 7.23, 4.38. In other words, that, in my case, because I'm not sliding the vector because of the fact of you can use the rule of transmissibility, in this case here, you know that in fact the tooltips gives you 4.38, and it gives you then, and this is not the easiest, but we'll do it, 5.1 and minus 4.38. 5.1 and minus 4.38. Now these numbers here are not related, this number here and this number here, but let's double check them one more time. 7.23, 4.38, 5.1 minus 4.38. And now you have to, when you look at a problem like this, you need to step back very early and see if you know the solution. And in all reality, the solution is, looking at this, all of the y has to be here and all of the x has to be over there. But instead of that, let's just assume that we have a unit force 1 up here and it has to react at a distance of that 12.33 to the magnitude of that moment. And so the magnitude of that moment here, and I'll kind of go right here, equals, right, 7.23 to minus 4.38. And we can bring up one more. If we can overwhelm the screen, let's overwhelm the screen. This is why you carry around a calculator. And so right here, I'll put this one off to the side here, and you can plug in, right? You've got some information there, some information on a sheet of paper, and then you turn this on, hit the clear, and you say, well, 7.23 times 4.38, and of course that was negative, meaning it spins in a negative direction, so we're going to go back here and try to set that in to be a negative 4.38. That gets us a minus 31, and then we can say plus or minus, as your case may be, minus 5.1 times 4.38. It should give us a big negative number, and now you just need to know, going back over here, you need to know that the distance between those supports, in other words, the reactive force there is 12.33, so you take this number and you divide it by 12.33. And that gives you the reaction at B. This is going to be, what we said here a second ago, is minus 54, whatever that number was, we lose it when we go here, divided by 12 if you would. And that turned out to be, right, you have to realize this is going up. It is 4.38 up. Why? Because this is a minus 54 is the torque, and the other one is actually the torque of that little force there, and that's got to spin opposite or in a positive way at a distance of 12.33. You get a reaction of 4.38 up. Now, I want to point out that I'm going to show you here once again that you can shift here. All of a sudden you have to realize that this position of this force right here, if you're writing it over here, you need to shift every vector over by 12.33. And so this becomes a negative. If this is 12.3, it's 7.23 minus 12.33. Or if you did the shifting, it would just be right there at 0. But this is the sum of the moments about A, and now we're going to do the sum of the moments about B. And how do we do that? Well, we can go over here, UCS, from the end point there, hit an enter to accept, and now this time we have our vector beginning at minus 5.1 and 4.38. So that one there is minus 5.1, 4.38. And realize the force hasn't changed. It's just our coordinate system. And so again, this is 5.1 and minus 4.38. And looking at that, you should realize that this is a positive and this is a negative, and though this, of course, this moment equals 0. Which is course of what you know, that all of that is going through there, so this reaction, the reaction at A in the Y has to be equal to 0. Now the final piece to this that will fit within the 10 minutes, again, looking at a problem like this and getting it right, you want to do that because this is a problem you should be able to answer. By logic, this force is right on top of that, and so all of the Y should be reacted to here, and by logic, there is only one place for this to react in the X direction, that is there, so all of that force should be there, and so in the end, you should have 4.38 here, and that should have minus 5.1 there, because it all has to react to that. That said, however, once you know this value here of 4.38, you should draft it up. I'll do that by saying line from the end point of that, and then at 4.38 straight up. Now you do that, and this next step you see many people will skip, but you want to develop the affinity all the way back in physics for solving for the moment and checking for the forces. I'm going to do that now by saying X line from the end point of there to the end point of there. That gives me one line of force and another X line. This one is going to be a vertical through the end point. And now I have that little circle up there. That little circle. I draw out the intersection here. Line, circle at the intersection. I can get rid of my lines of force, and what we have here, remember we solved for this, and if this is 4.38 times, this is the moment arm distance, and so you can do any number of things. Realistically, you can do this, UCS, center of that, and then hit an enter, and now your UCS, ID, center of this. You could say, now doing again, that force, you could write that matrix out. It's kind of foolish at this point to do that, but you could write that out and realize that this force times distance equals this force times distance. But realistically, you could just do this. You could list that, that's at 0, 0. You could do an ID of the endpoint there and realize that's 10.57. This is 12.33, therefore it's closer. Therefore, it's going to have to be more. So you can take 10.57 divided by 12.33 and get your reaction. So let's see if we can get that calculator back here. So you have to realize that this reaction in this direction will be 5.1. When you take this, force times distance equals this force times distance, or just the ratio of the distances, you get 5.1 in reaction. We'll do 2 more problems like this. You need to try to look at them, get them, and start to applying these tools to do it relatively efficiently. You want to be able to get this skill mastered. Thanks for listening.